All right, Unit 5, Day 1. Some new vocabulary coming at you as well. Right away, the new vocabulary. Concurrent lines. Concurrent lines. If you read the definition, 3 or more lines that intersect at a point. So in that first box, can we do our best right now to draw 3 lines? You don't need a straight edge or a compass to do this. Just draw me 3 lines that all intersect at the same point. 3 lines, line 1, line 2, and make a third line that intersects at the same point those two do. Those 3 are called concurrent lines. Why? They all intersect at the same exact point. And you can put that point right on there if you'd like. That point has a special vocabulary name attached to it. The point where concurrent lines meet is called the point of concurrency. That's the point where all the concurrent lines meet. All right, so instead of saying that point, the point of intersection, we call it the point of concurrency. All good. So concurrent lines, 3 or more lines that all intersect at the same spot, that spot, the point of concurrency. Circumscribed versus inscribed, number 3 and 4. Circumscribed versus inscribed. Circumscribed. Everyone draw yourself a circle right now. Go ahead, draw yourself a circle. Circumscribed means the circle is on the outside of my triangle. The circle is on the outside of my triangle. Now what I need you to do is draw a triangle inside the circle, but make sure all 3 vertices touch the circle. So that's a little too big, so just let me scale it down. Make sure all 3 vertices touch the circle. There it is. So we say the circle is circumscribed. Circumscribed around the triangle. It's on the outside. What if I flip it now? What if the circle's inside? I call it an inscribed circle now. All right, an inscribed circle. So everyone now draw your triangle with the circle inside. Make sure the circle touches each side of the triangle. There we go. Circumscribed, it's on the outside. Inscribed, it's the circles on the inside of the triangle. All right, what does this all have to do with triangles? Today, our focus is going to be on a certain set of lines that are concurrent in a triangle. And you're going to find what those lines are right now. So I have triangle ABC. Go ahead, everyone, plot triangle ABC for me. 1, 3, 9, 5, 7, -1. Go ahead and plot that triangle. Oh, shoot. Make sure you label the vertices A, B, and C for me. Okay, here's what we're going to do. We're going to find the midpoint of each side now. Midpoint, and you'll see where we're going with this. Find the midpoint of each of the sides. Let's do a quick review. Midpoint formula. I'm going to take my x's and add them, divide by 2. I'm going to take my y's and add them, divide by 2. I'm going to make this easy, and I want to make it go quick. All right, I want this to go quick. Here we go. This row right here. You guys are going to find, you guys are going to be group 1. Find the midpoint of AC. You guys are group 2. Find the midpoint of BC. You guys are group 3. Find the midpoint of AB. All right, so go ahead and find your respective sides midpoint.
What was that again?
Group 1.
Yeah. Finding which one?
Group 1. Do we see group 1 on your paper?
Oh.
Hi.
Yeah.
Hi. Yep. You guys watching this on Geometry AB, just find the midpoints of as many sides as you can right now. All right, let's go over the midpoints here. Group 1, midpoint of AC. What do you have?
4-1.
What do we have?
4-1.
4-1, confirmed, 4-1. Okay, call that point D for me. Point D, 4-1. Graph it as well now. Graph it, 4-1, midpoint of AC, 1, 2, 3, 4, 1. Graph it, call it point D. Group 2, what'd you find the midpoint of BC?
8-2.
8-2. Call that point E for me, please. Is 8-2. And graph it. 8-2, graph it. It should fall right on the line we're finding the midpoint for, which it does. Everyone good so far? Midpoint of AB, group 3, what do you have? 5-4, call that point F for me. Everyone go ahead and graph 5-4 as well. Should land right on AB. Point F, there we go. So all we've done so far is find the midpoints of each side. Now we got to do more, because I want you guys to tell me at the end what we're forming here. Now we're going to do slopes. Rise over run. Change in Y over change in X. So you, again, slope. You got 2 options right now. You can do rise over run, or you could say it's Y2 minus Y1 over X2 minus X1. Same sides, same groups, same sides. So all I want you to do is find the slope of your side right now. Find the slope of your side. You can do the Y values over the X's, or you can do rise over run to find the slope. All right, so go right ahead. Find the slope of your side. Back to the slopes. Slope of AC, group 1. What did you get? Slope of AC. Negative 2/3, everybody. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. It was 4 over 6, but we can reduce it to negative 2/3. Why is it negative? It's going downhill, right? How about group 2? What was your slope of BC?
3 over 1.
3, 4, 5, 6 over 2. 3 over 1. I'm just going to put 3. What was the slope of AB? Final group here. Slope of AB? 2 over
8.
1, 2, 3, 4, 5, 6, 7, 8. 2 over 8. I'm going to reduce that down to 1/4. Yep. Okay, everyone caught up here, because now here's the big part we're going to do here. For group 1, and anybody can answer this. For group 1, what's the slope of a line perpendicular to AC? It was negative 2/3. We talked about this a couple units ago. So what would be the slope of a line perpendicular to it? Negative 2/3 was the slope. What do I need to do to find the slope of 2 perpendicular lines? Come on, dig deep, Tim. Negative reciprocal. Negative 2/3. Flip it and change the sign. What's the slope? 3 over 2. All right, so here's what I want. Everyone, ready? Go to point D, the midpoint of AC. Go to point D. And from point D, I want to go up 3 over 2. I'm making a perpendicular line through AC. So everyone go to point D, the midpoint, and now use the perpendicular slope. Up 3, 1, 2, 3 over 2. If you want to graph another point, up 1, 2, 3 over 2. Grab whatever straight edge you have right now. Grab whatever straight edge you have. And draw your line through. Everyone has that line in. Okay, before we move on and do it 2 more times, I need a vocabulary term for that line we just grabbed. I need a vocabulary term. It went through point D. What was point D? Midpoint. What do we call anything that goes through a midpoint? Okay, so bisector. And we're guaranteed that AC and this line are what to each other? Perpendicular. We just did the slopes. Let's put them together. What's that line you just grabbed? That's the what? Perpendicular bisector. Correct. That is the perpendicular bisector of AC. Everybody stop. Still. If that's the perpendicular bisector, name 2 segments that are equal. AD is congruent to DC. Nice. And do you see where right angles would be formed? Yes? On either side right here of AD, I would have right angles. Okay, so yes, AD, and don't mark this because it's going to get messy. AD congruent to DC. And I would have right angles. All good. So why are we doing this? Well, I still got 2 more to go. I want 2 more perpendicular bisectors graphed, and then you'll see where the magic happens. All right, group 2. Your slope was 3. So what's going to be the slope of the perpendicular line I'm about to graph? Negative 1/3. So everyone go to point E. Everyone go to point E. And do a slope of negative 1/3. So where do you guys want to do here? You want to go down and over? You want to go up to the left? What do you want to do here, kids? All right, ready? So from point E, down 1, right 1, 2, 3. Down 1, over 1, 2, 3. Line those up with point E, and let's draw in your second perpendicular bisector. Straight edges are important here. One more time. Oh, go ahead. I'll let everyone draw it in. Sorry. Getting too fired up because I know what's going to happen next. Everyone ready for their third and final perpendicular bisector? All right, group 3, your slope at AB was 1/4. What's the slope of my perpendicular bisector I'm about to graph? -4. Good. Let's go. Let's go to point F. Where do you want to go? Up and to the left or down and to the right? Sure, you got it. Everyone go down 4. 1, 2, 3, 4 over 1. Do I have enough room? 1, 2, 3, 4 over 1. Good. Uh-oh. Oh, yeah. Here we go. Line it up. Let's see what happens. Oh, oh. Look at that. Look, oh. You're not feeling it, are you? You're not feeling it. Nobody's feeling it. Okay. I'll just do it. Go solo. Those are three perpendicular bisectors. All three. I can't draw in a fourth or a fifth. That's every single perpendicular bisector that exists in the triangle. Three of them. What do you notice? Thank you for using the vocab. They don't say, oh, they all intersect. We got words now. What are those? What's that vocabulary term again? All three perpendicular bisectors are concurrent. Correct. So are these lines concurrent? I'm just going to write yes. I would like to write darn right, but we'll just put it there. Yes, they are concurrent. And see where they're all concurrent at? This point of concurrency, I got a name for it. This is your big vocabulary term for the day. The point where all three perpendicular bisectors meet, let me say that again. The point where all three perpendicular bisectors meet is called the circumcenter. Isn't that kind of almost like a word we just talked about maybe like 5-10 minutes ago? Mm-hmm. It's similar to what word? And there's a reason. And I wish we had more time to do it, but if I had you guys take your compass right now, put your compass point on the circumcenter and your pencil point on one of the vertices, you could make a perfect circle that would hit each of the vertices. And where would that circle be, on the inside or outside? Circumcenter, right? Circumscribe. That's what it means, okay? So where all three perpendicular bisectors meet is called the circumcenter. We all right?
What are the conclusions?
What?
It says conclusion. Oh, that's it.
Yeah, that's it. There's my conclusion. Hold on. Ready? Or some of you guys are trying it. Does it work?
Yeah.
Darn right it works. Not fooling you guys. Circumcenter is where all three what intersect? If we don't get that, we got more to go too. The circumcenter is where all three perpendicular bisectors meet. What's the point called? Where all three perpendicular bisectors meet? Circumcenter. All right, last thing before we get into practicing. What's so special about that point other than its name? All right, that point has a special property. We already have the name for that. Here's the theorem that goes along with the circumcenter. The circumcenter is equidistant from the vertices of the triangle. All right, the circumcenter is equidistant from the vertices of the triangle. What does that mean? All right, here we go on my diagram. O is the circumcenter. All right, O is the circumcenter. So what's so special about it? Ready? What are the three vertices of my triangle here? What are the three vertices? A, B, and C, right? So everyone just draw from O to B a dashed line. From O to A dashed line. And from O to C a dashed line. Those three are all congruent. OA, OB, and OC are all congruent. That's the special property about a circumcenter. Wherever that point is, it's equidistant from all three vertices. Okay? It's always equidistant from the vertices. We okay? Circumcenter, how's it formed? Intersection of the perpendicular bisectors, and it's equidistant from the vertices. Three vertices of a triangle. A lot of vocab, huh? A lot of vocab. Any questions right now before we try to find the circumcenter on your own? Yeah, darn right it works. You guys think I'm just throwing this at you? Like, I'm just, just believe me? Come on. Better than that. All right, let's find the circumcenter. Where should our mindset be now? I have a problem. Here's a triangle. Find the circumcenter. Oh, here's where my mind should go. Circumcenter. I'm thinking the intersection of what? Perpendicular bisectors. Now, good news. I don't need to go through all that midpoint, slope, negative reciprocal stuff here. What type of line is BC? You tell me straight. Get out of here. What type of line is BC?
Horizontal.
BC is what type of line? Horizontal. That's what I was looking for. Okay, horizontal.
I said that. You
Great,
sound like
great job.
Rebecca.
Yeah, I heard her. I was listening to all the other stuff that was just pouring out that people are just throwing vocabulary at. Side, side, side. No, relax. All right. Yes, it's horizontal. What's always perpendicular to a horizontal line? Oh boy. A vertical line. But this vertical line's got to go through the bisector, the midpoint. Can you draw in the perpendicular bisector on your own here for BC? I don't need to do all the crazy math I did on the last problem. All right, can you draw it in? A vertical line going halfway through BC. That's its perpendicular bisector. Can you do it for me? How long's BC? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, halfway. There it is. I'll make that a little better. There's your perpendicular bisector. We're all in agreement? I don't have to do any fancy math there. What other side is it going to be also easy to do a perpendicular bisector for?
AB.
The vertical line, AB. Go ahead. Do a perpendicular bisector for AB now. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, halfway. And then which side is it going to be a little bit tougher to do the perpendicular bisector for?
AC.
The hypotenuse, right? Hey, kids, do I even need to do it? Do I even need to find the third one? Don't you already know where it's going to intersect? Right? If we did these two correctly, which we did, shouldn't we already know where the circumcenter is going to be? I don't have to waste my time figuring out, is it here, here, here? All right, I don't have to do that. All right, I don't have to do that. Where is it going to intersect? Where the first two already intersected. There it is. There's your circumcenter. I just have to find the coordinates now. Does that make sense? That I don't have, if I did the first two correctly, I don't need to do the third bisector because I know where it's going to intersect. And what's my coordinate here?
5, 5.
Is it?
Yep.
Yeah, it looks good. 5, 5, circumcenter. It's not a cheat code. All right? If you did the first two correctly, you know where it's going to be. Questions? Going. What's so special about it again? What's so special about that 0.55? Come on, what's so special about it? Equidistant from what 3 points? A, B, and C, right? So again, I'm going to keep harping on this. This distance is the same as this, same as this. Look, they're all the same because that's the circumcenter. All good. Last one here. Oh, yeah, let's go in the kitchen. What do you say? I got a stove, sink, and refrigerator positioned in the kitchen somewhere. I need some help, though, from you guys. I want to build an island. All right? Not like a desert island. All right? You know what I'm talking about? The little thing in the middle of the kitchen there. So it's the same distance from these three appliances, the stove, sink, and refrigerator. It's got to be equal distant away. Equal distant away. This is another way of me saying what? Same distance from these 3 points. I'm asking for the circumcenter of those three, correct? So if you want to go ahead, take your straight edge right now, connect them to form a triangle. This is another way of me saying find the circumcenter. Because that's the point. That's the point that's going to be equidistant away from those three. Ooh, how are we going to do this? It's the only one you have right now. Circumcenter. That's where all three what are going to intersect. All right, so circumcenter. Here's where my mind goes. Perpendicular bisectors. And that's why you brought your compass and straight edge with you today. We're going to do the perpendicular bisectors for at least two sides. All right, at least two sides. All right, anybody have a preference? Pick up your compass and straight edge. Let's get to work. We've already done this construction this year. I'm going to have to review. What do you want to do first? The side perpendicular bisector for what side? KR. All right, anybody remember how to do the perpendicular bisector?
Yeah.
Put your compass point on KR, open it up.
More than half.
More than half the distance of KR.
Yeah.
Thanks for the confirmation. A decent size arc, right? About a half circle type arc. And then go where? Keep it the same opening and go over to R. You guys watching the video in Geometry AB, you can certainly pause it so you can do it yourself and then play it again to see the next steps. Now what? Grab your straight edge, draw in your perpendicular bisector. Done. There's one. You're going to need at least two. So anybody have a preference? Actually, I don't. Why am I asking? You guys do whatever side you feel like. Go. And I'll do whatever side I feel like. You do you, I'll do me. Yep, you're going to have a lot of arc marks here. We got to deal with it. Doesn't matter what sides we picked. We should all have the same circumcenter. That is where I should be putting my island. So it is equidistant away from the kitchen, from the sink, stove, refrigerator. Now, if you wanted to do the third one as just a check, you could, to make sure the first two are correct. All right, but if you're happy, satisfied, I'm not going to force you to do a third one. The third one I just call a check, just to make sure it does go through the other two. Questions? Anything? All right, I know how tough this is, so instead of just feeding you to the wolves right now, aka your homework, we're going to start the homework together. All right, so if we go right up to the bell, we go right up to the bell, but I want to at least start the homework with you so you have an idea of what we're looking for here. All right, so let's see how much we can get through here. All right, I'll do as much as we can together. The perpendicular bisectors of triangle ABC meet at point G. Stop, stop. Start doing this, please, in the directions. Point G. Perpendicular bisectors meet at G. G is what? Circumcenter. Circumcenter. Meaning, this is where your mind, I got to get your mindset. So point G is equidistant away from what? A, B, and C. So name me 3 line segments right now that should be congruent to each other. This is where I need you to be, guys. Name 3 line segments. If G's the circumcenter, that you know are going to be congruent because G is the circumcenter. Go. G to A. Vertex A. G to B. And G to C. They're all congruent to each other based on my property of a circumcenter. We're all good? All right, let's see if we can answer these. Find the length of AG. Find the length of AG. That's not 24 is AF, by the way. AG. Well, what do you know AG is congruent to? Isn't it congruent to GC? What's GC? Okay, see how this is working now. But I gotta know the vocabulary and the properties. I gotta. And practice it. BD. BD. Ooh, ooh. Stop. Everybody stop.
Oh, it's not.
Stop. What is DG? If G's the circumcenter, what's DG then? A perpendicular bisector, isn't it? So you tell me now, if DG is a perpendicular bisector, how long is DB? 20, right? AD and DB are congruent because that's a bisector. So that's got to be 20. I got to know what's all related. Perpendicular bisector, circumcenter, equidistant from the vertices. How about CF? 24, because GF is a what? GF is a perpendicular bisector. BG? 25, equidistant from the vertices. CE? Perpendicular bisector. So it's got to be 15. How about AC? Adam, oh geez, I asked for adding there. 48. Questions from you guys? See how this is working now? I got to know what's the circumcenter is equidistant and it's formed by the perpendicular bisectors. Anything you want to ask before we get to the next one? Next one's a little crazier. All right, while I'm cutting and pasting that one, go ahead. Take a look at it. Label your diagram. Answers are all up on Classroom for the ones we don't get to. Come on. This one's a tough one. But we're not going to shy away from it. All right, let's go. Perpendicular bisector. So what's point G again? Circumcenter. Special property, equidistant from the vertices. So again, GA is going to be the same length as GB, same length as GF, right? All right, what was I given here? BC is 12. What can I put on BE and EG now if that's 12? If that's 12, what's BE and EC going to automatically be? 6 and 6, because GE is a bisector. What else do I have here? GE is 3.
Wait, I have a question.
Yep.
Why would it equal GF and not GC? Like GA equals GB.
Oh, what did I put? GB. You're right. I should have put GC. Yep. Thank you. One job. There we go. And GE is 3. Got it. All right. We got a little work to do with GA, right? Because right off the bat, I'm asking you to find GA, and I know nothing about it. Do I know GB? Nope. And I don't know GC either. So I'm kind of stuck. Everyone agree? I don't know. I'm looking for GA, and I don't even know the lengths of the other two that they're equal to, GB and GC. But you can find it. Hey, we can find what GB is. We can find what GB is. How? Ready? What's GE again? Yeah, I know. But what's the name of it? If it's meeting at the Circumcenter, this is a what is a perpendicular? Forms a right angle, right? And it bisects, that's why I have 6 and 6. Anybody see how we can find GB maybe? I got myself a right triangle here, GBE. I got 3 and 6. I think you guys have been exposed to this. HL. Oh, we're finding a line segment. If I know 2 sides of a right triangle, how do I find the third? Anybody? Pythagorean Theorem? Yeah, no?
Yeah.
You guys have seen that before or no?
Yeah, we did that like the second side of the grade.
Okay, well, I don't, I'm supposed to teach it later on this year too, so that's why I'm asking if you guys have seen it before. All right, Pythagorean Theorem, yep. So I can say 3 squared plus 6 squared equals c squared. And then you guys, how much time do I got left here? Yeah, only 15 seconds. 9 plus 36 equals c squared. So you can leave it 45 equals c squared. And what do you do at the end? Square root. So c equals the square root of 45. So there is GA. And you guys should be okay for the rest of it. Okay, so there's GA, which is GB as well. All right, see what you can do. Chromebooks coming tomorrow.